last test we will do, it will be related to adhesion. We will test one glue, how it behaves with our products, and I will ask Martin to introduce you the test. It's kind of very simple one. Once we would like to have endless board and we will need to glue it together, because those pressure machine, I guess, will not be in real continuous machines. You have to deal with gluing, so that's the reason why we choose also test glue, how this related to standard values, reference values. Okay.
Hello again. So the last test we will do, it's the combination of tensile shear strength of lap joints, and it's also, as it was said, quite easy test. So what is it good for? We actually, maybe it's good to say that there are also some pre-treatments which are a little bit like prior to this test. So there are some treatments that those samples are exposed to, and then these standards EN 205 is kind of applied, and we want to actually find out the resistance to hot or cold water of the glue joint, and also we can use it, of course, for determination or assessment of strength of bonds with a thin or thick bond line. With thin or thick bond line, there will be some pictures to explain what's the difference. This is the aperture. What we will use, a little bit different one, but it's the same principle. So actually we have two adherents, and then we have the adhesive in the middle, and we use the force to pull each other different directions, and then we actually find out the total load which is able to stand the material or the adhesive. Here I have some preparation of bond assemblies. This is like a drawing what it should be when we want to extract the samples from the board. So we actually use two boards which are around 130 millimeters wide. Then we have a thickness of 5 millimeters. There are two different thicknesses for thick bond line and thin bond line. And then if we want to make this thick bond line, we should make grooves which are 14 millimeters wide. But there will be one more picture to see more clearly. Also, before gluing, we should assure that they are stored like at certain humidity and also temperature, like 20 or 23, 65 or 50. Then not more than 24 hours before bonding. We should also lightly sand each surfaces which are going to be bonded. We use 100 grains for that. And we also should remove any dust carefully. Do not touch or soil the prepared surfaces. And then according to the producer of the adhesive, you should also attempt to the amount of adhesive to be applied, and also all those instructions that are given by producer as a duration of the assembly and pressure and assembly and open time and so forth. Here I put also some pictures for you, some sequence of production of those samples or how to make the samples, so you have at least some idea, because you will already just be given the samples, and so just to see maybe some background like how it was made. So firstly, some boards are cut of certain thickness, which was like 5 millimeters. Then, as was shown, some sanding, applying glue, and then some pressing. Then samples should look like those boards from which we're going to cut. The samples should look like in the picture in the right upper corner. Then we also remove some excessive adhesive, some storing. It should be stored like this because we shouldn't like place it at any position, so there won't be any kind of pressure or load introduced during storing. Then we cut it to, I think it should be 150 millimeters long. And now we're making grooves on samples, which are still like in the basic shape. We should also cut away 7.5 millimeter from both edges, maybe to avoid some defects. Then you can see finally cutting individual specimens for samples and sorting, grouping. That's the D1, D2, and so on. It's a category of resistance to water, I would say, and some rush conditions. D1 is the lightest, and D4 is like the strongest. It's like water.
We will do D2 or D1?
I think we will only put it in the water for cold water for 24 hours. So I think it's D1 because D2 is already boiling included, so probably only D1. Well, I'm not even sure if D1 has any placing into the water. But so for D4, you should also boil it for some time. Then also it's cooling in some process that repeats a couple of times. And then after all these pre-treatments, we can finally approach to the test. So that's the background behind the sample preparation. Here is, like I said, a little bit better detail for the samples, geometry or kind of measurements or dimensions of it. We also should like maybe just be careful with the rings. They should be in the angle of 30 to 90 degrees according to the standards. This is for the thin bond line and this is for the thick bond line. The difference is that we actually use 1 millimeter bond line for amount of glue that is spread on that surface which is loaded. And in this case, it's only around, but it's like 0.1 millimeter or less, plus minus some kind of allowance. So the surface which is bonded is around 10 millimeters wide, or actually long, and B it's the width of the sample, which is 20 millimeters. And from these two parameters also the equation kind of counts. And it should be long 150 millimeters. And the difference is in the thick bond line, that one plank is 6 millimeters and one is 5 millimeters, opposed to the thin bond line, which is both the same. So these are like number of test pieces, so we should make at least 10 for good statistical results. And then also if there is some failure which is a little bit doesn't occur in wood, we can also probably count it as invalid, because I think this rupture should occur in wood and not in glue, because glue should be stronger than wood itself. The bond itself should be stronger. So we have to also kind of visually maybe observe the rupture if the bond was properly bonded or applied. And again, there is some expression of results with the classical equation. So as I said, A was the area of bonded of the sample, the area where is the glue applied, and if you just a little bit divide it to smaller parameters, it's this L2 and B, and it's maximum force divided by that area. So that's all science behind the calculation. And then from the results we can get some idea like what parameters or what kind of result we want to get out for this test. So for sure we will want to know like the maximum force, and then we can also observe like how much maybe wood it's still on the bonded area, or if there is some kind of missing place, so we can maybe visually observe if it's 25%, 50% or more. Then we have some breakage of fluids, some mean values or any standard deviations and so on. I'm not sure like what, how many of results or kind of data we can, how much data we can get, but there will be probably just some computer measuring all this data. So it's probably up to you like how much of it you wanna calculate. Okay, I think that's it for this test. Do you have any questions? Thank you.